couple review problems. So I'm hoping these don't take you very long to do. That's a 9 and a 5. So if I have x to the 9, x to the 5, what's the rule here? Add them, so x to the 14. I hope is what you're getting for that one. The next thing, if I have x to the 6th over x to the 3rd, I'm going to subtract them. This one just looks like x to the 3rd. But if I do it with the larger one on bottom, what ends up happening? What is this going to look like?
Be a negative, but you're gonna have to divide it.
Yeah, you can tell me x to the minus 3rd, but really I want to look at it as positive, so that's going to look like 1 over x to the positive 3rd, right? So I'm hoping you probably this is fine if your brain's going there, but I'm really hoping you take it one extra step.
Yeah, and they'll ask. Usually the directions say to leave with all positive exponents. So.
And the last thing, x to the 50 to the 3rd, this is going to be x to the
150.
150, is that what I heard? It's kind of a blip, but I think that's what I heard. Okay, so that's just a quick sort of review of the things we did last week. We slept on it. This is our work for today. Before we get there, I do want to watch a short little video. I think it would be beneficial. Am I recording? I'm recording. Okay. So I'm going to share my screen. This is the one I want to share. Can y'all hear that?
No.
It's not audible.
No, I can't.
Okay, I think I can share it with sound. No. Share computer sound. There we go. I think this should work. Video clip. Okay. So optimize screen sharing for video clip and share my sound. And I think hopefully. Can you hear that now?
Yeah, much better.
When I was young, I always felt like I was being judged. At the age of 7, I had developed a severe stutter, and I feared that I might not be as smart as the other kids in my class. In school, I had one all-consuming goal: don't look stupid. In my head, I'd always be thinking, what are the chances that I'm going to stutter and look stupid in this situation? If the chances were high, then I would do anything I could to avoid that situation. It wasn't until I read the book Mindset by Carol Dweck that I really understood my constant fear of judgment. In the book Mindset, author and renowned psychologist Carol Dweck explains that the constant fear of judgment and the need to avoid looking stupid stems from a core belief people have about themselves and everyone around them. That belief is, everyone has a set amount of intelligence. From that belief, the logic goes, if I only have a fixed amount of intelligence, and if I start making mistakes and look stupid doing something, then I must not have very much intelligence. Dweck calls this underlying belief a fixed mindset. If you have a fixed mindset, you essentially believe you've been dealt a hand of cards in the poker game of life, and you're stuck with those cards. If you happen to get good grades in school, and your parents praise you for it, then you might start to believe you've been dealt a royal flush. But as you get older and face competition in school, make mistakes on tests, and encounter challenging situations, you start fearing that the hand you've been dealt really isn't that good. To maintain the illusion that you're still smart and special and talented, you avoid doing anything that you might look bad at, and you simply lose interest and stop trying. Because if you show that you don't care and you're not really trying, then people can't really judge your full ability. Author Carol Dweck has seen this pattern emerge over and over again in her research. In one study, she gave 5th graders a group of puzzles to solve. Each of the puzzles was within their current puzzle-solving ability, and all the kids loved them. But when she increased the difficulty of the puzzles, the children who had been praised for their puzzle-solving ability and developed the belief that they were gifted showed a steep decline in interest and effort as the puzzles got harder. However, Dweck found that there was another group of children who didn't shy away from the puzzles once they got harder. When Carol asked them why, they said the puzzles were an opportunity for them to get smarter. These kids took the initiative and asked Carol Dweck if she could write down the names of some of the puzzles so their mom could buy more when they got home. These kids had what Carol Dweck calls a growth mindset. Growth mindset people don't believe talent and intelligence is a gift. They believe you have to work for it. A person with a growth mindset firmly believes that with the right strategy and enough effort and time, they can get better at anything. A growth mindset person believes they're always getting smarter, so they're less afraid of being labeled stupid. They know that even if they've been dealt a bad hand in the poker game of life, they can continue to draw more cards by putting in more effort and finding better strategies until they eventually have a great hand of cards. Now, this growth mindset seems inspiring. It seems cool to be able to grow our intelligence, but is it actually true? Well, 40 years ago, the answer would be no. Scientists at the time thought you could grow a little, but you were largely constrained by the default wiring of your brain. But recent science shows that they were mistaken. Based on other books I've read over the years, I've learned 3 amazing ways you can change your brain. Regardless of how old you are, you can physically grow your brain, you can speed up the circuits in your brain, and you can rewire your brain for increased performance and intelligence on specific tasks. Several years ago, before taxi drivers used GPS to get around, brain researchers took brain imaging scans of experienced London taxi drivers. Researchers noticed that the more time a London taxi driver had spent driving a taxi in London, the larger a region of the brain associated with spatial awareness and memory, the hippocampus, had become. It was apparent that the more demands the taxi drivers put on their brains, the more they had to navigate the challenging road system of London, the more neurons they were able to grow in an area of the brain that they needed to complete their job. But not all brain regions can expand in size. So, other brain regions just make circuits faster. This is done by the process of myelination. As I briefly touched on in my deep work book summary, when you focus intensely on a single subject for a period of time, you start forming white sheaths on your brain cells called myelin. This myelin acts like insulation on an electric circuit. A brain circuit with myelin can transmit information up to 10 times faster than a brain circuit without myelin. After you've added as much myelin as you can to brain cells, you can then increase the capacity of your brain by rewiring it so it activates neighboring brain regions to assist with certain tasks. You can think of this like rewiring a house, so that when you hit a switch to turn on one light, you actually turn on 2 or 3 additional lights nearby. One study showed that when a person practices guitar for hundreds of hours and uses their fingers in their left hand to play the different notes on the strings of the guitar, they light up regions of their brain associated with the left fingers, no surprise. But they also light up regions of the brain associated with the palm of the left hand. When researchers took brain scans of novice guitar players, only the fingers in the left hand were activated in the brain. It turns out that guitar players who had put in hundreds of hours of practice were able to activate more of their brain so they could play the guitar with more speed and accuracy. Now that I know that I can grow my brain's capacity, I think about challenges in a new way. Before I go into a challenge, I stop thinking, will I look smart or stupid while doing this? And start thinking, what can I learn? After a difficult challenge and a series of mistakes, I stop thinking, I'm not smart enough to do this, and start thinking, I'm not smart enough to do this yet. Now that I've changed my core belief to everyone can grow their cognitive abilities, I am less afraid of being stupid because I know I am continuously getting smarter. Even if I look stupid now, I won't look stupid very long if I apply enough effort and the right strategies. I now have the courage and confidence to go into challenging situations because those situations will allow me to upgrade my brain and learn the skills to overcome future challenges. That was the core message that I gathered from Mindset by author Carol Dweck. Reading this book will set you on the path to becoming an infinite learner. I highly recommend it. If you would like a 1-page PDF summary of insights that I gathered from this book, just click the link below.
Yeah. Okay. Hush. Okay, so why did I share that? Why would I post that in here? What's the purpose?
Get us more involved.
Get you more involved. That's probably not a bad response, but I mean, like, what sort of pertinence does it have to the class? I guess is what I'm asking more. Yeah, I think the thing I really want to focus on is like the growth versus like the fixed mindset, right? There's that
Carol
other.
Dweck is my idol. Love her.
The rest of it is just kind of sort of like justification for why that sort of thing is a thing, right? I feel like most of it is based on the fixed versus growth mindset. So if you approach things and I hopefully none of you take I hope none of you take my gradings like personally, like at all, right? I don't even know what grade you make most of the time. Like I grade the work, not the person for the most part. I don't look at the name. I'm just grading work that's there. And so hopefully you don't take that personally, right? Because that's part of fixed mindset. And I don't know if I've heard so many videos on this, so I don't remember if he elaborated on it. But fixed mindset people, they typically they're not as successful as people with growth mindset, right? If you have a fixed mindset and you don't think you're ever going to do anything, then you're probably not ever going to do anything, right? Sort of thing. It's going to self-fulfill itself. And so I think everyone is capable of getting through this class. I guess I could say that. I wouldn't be here if I didn't think you were not capable of learning this, right? And so I hope you approach these things with a growth mindset. I hope you don't take things personal whenever you get things wrong in this class. But I hope you do like look at it as this sort of perspective of like, what can I learn? What can I learn from this, right? What can I learn from these marks that are on my paper? If you're getting everything right, then what the heck are you paying me for, right? Like to some degree, it's like why am I here? I'm just here just to talk about things, I guess. I don't know. But yeah, I don't know. I've kind of heard that adage growing up, right? If you're getting everything right, then you're not learning. So sometimes, I don't know. And it's a hard thing to do. Like, I am not saying I don't struggle with this. And it's not saying that there's not other things out there that might affect this, right? That might affect your mood, that might affect what's happening. There's a whole world out there around you, right? So I don't think they're like saying or trying to deny that there's other factors, that there's social factors, that there's other things out there that might affect you, right? But what they're trying to do is try to give you a mindset that is going to be beneficial to you, that's going to help you, right? And that's what I hope you can take from that, at the very least, hopefully. Any questions, comments, any input? Have y'all heard of fixed versus growth mindset sort of thing? The research being done there?
Covered it in my UC class a couple weeks ago.
Yeah, I guess it kind of correlates with like nurture versus nature, right? But not directly. Like it's a little bit of a different thing.
I've met her in person. She's
Definitely
awesome.
good encouragement.
Yes.
Okay. So I guess we should get started with doing some of this work. Ooh, yeah. So the following exercises determine if the polynomial is monomial, binomial, trinomial, or other. So if it's 1, 2, 3, and then they're just so lazy, they just call everything else a polynomial, right? Anything larger than 3, 4, or more terms would be polynomial.
I guess that gives C away.
Well, they actually have names for some of them, but we don't use them because they get to be ridiculous.
Okay.
Real quick, I actually had a question on 7D for that one. I just put difference of squares.
Which one? This one?
Yeah, no, D.
So they're asking you monomial, binomial, or trinomial. So they're just asking you how many terms.
So it would be binomial?
Yeah, that's a binomial.
Yeah, I just got confused because when I was watching the video, I know you were breaking them down,
Mhm.
especially when one coefficient had two variables. So I was just like,
Yeah.
Okay.
So like I think it did mention like the difference of squares. But if this was a difference of squares, they would have to be both be square numbers. 14 is not a square. So I think you're thinking like maybe like 7 squared would be 49, right?
Right.
Yeah. Okay.
Appreciate
So that's a binomial. This first one, how many terms does it have?
2 binomial.
2. This is a binomial. So I'm hoping like this is not the super complicated thing we're looking. We're looking if there's an addition or subtraction sign in each sort of like thing on each side. That's a term, right? That's a term. So if you have to underline these things, if it helps you, you can underline each term. But this is how many terms?
3 trinomial.
3. This is a trinomial. That next thing is so many terms I don't want to count it. I'm just gonna call it a
Quadnomial.
what? Quadnomial. I don't even know if that's what it's called. To be honest, like I don't even know what they're called. I've like never really looked at them.
I don't use them either.
We just call them monomial, binomials, and trinomials are really the things that we kind of like talk about a lot. So we use a name for it, right? Kind of like Eskimos and snow, right? That
Yeah.
whole analogy. If you don't
I mean,
use it, then why are you talking about it?
You could go into the Greek or the Latin or whatever it is, so where you say quadrinomial, and then there's like hecta,
Hectanomial.
octo, for 8,
No,
stuff like that.
yeah, that's too much. How many terms are here?
Mono.
That's a monomial. And we didn't really talk about it, but I want to talk about the degree of the degree. So if I'm looking at this one, what's my degree here?
1 cubed.
So the degree would be the highest degree that you see there.
It's gonna be 3.
Yes. And maybe that's a little confusing because there's 2 variables. But that's 3. That's 3. It's the highest one that's there. And the other one we'll talk about, well, there's a little more there, but we'll talk about after this one. So what is this one? What's the degree of this one? A little more tricky. But if you have 2 variables, it's kind of stupid. It's what,
Is it
like
2?
probably the first thing you would guess on this. If you have 2 variables, you just add them. So we do 1 plus 2, it's going to be degree 3. And so like I was saying, this is degree 3. I guess technically this one's a degree 3 and this one's a degree 3 and this one is a degree 3, right? I guess everything in that one's degree 3. But when I talk about the degree of the polynomial, what I mean is the highest degree. If I talk about the leading coefficient, I mean the coefficient on the highest degree. Okay.
So what if it's just like C, or no, I'm sorry, E, that would be 1, right? The degree? 'Cause
This
it's a
degree,
number.
ooh, the degree.
No, it's gonna be 0.
Yeah, that's good. So this is like, if I wanted to write an X there, if I wanted to write a variable, I would have to write an X to the 0 degree. So really like the thing I hope you take home with this is that if you see a constant, there are no variables there. It is a degree 0. So I'm glad you asked that one.
Oh, but isn't, so, but what about like -3 to the first power? Isn't that still -3?
So -3 to the first power is absolutely -3, right? But
Yeah.
what we're saying when we say degree is we mean the degree on the variable.
Oh,
And so this is just a coefficient or a constant. If we put a variable here, it'd be a variable to like a 0 power.
oh.
On the other hand, if we have -3x, this is x being to the first power, this would be a degree 1, right? If we just say -3x.
Okay, so when it's a variable by itself, that's when we put a 1.
Yes.
Okay.
If it's a constant, then it's none. There's no variables there, so it's a degree 0.
Okay, cause so these are not like no solution or something, like there's always an answer. that.
So this, we're not even solving yet. We're just writing things. We're just rewriting terms. When we start solving we have to have like an equation. We have to have that equal sign. So these are just like rewriting terms. So in a second, we will like start putting these equal to numbers and stuff like that and solving them. But we're just doing like sort of like the operations you do to like one side or something, right? It's not actually solving yet. Just simplifying, I guess, is what it'd be called. So this guy, what am I looking at? What is the strategy if we're adding and subtracting?
Just combine like terms.
Like terms go together.
That's fine, like terms. So if we look for like terms, I believe what the x's, I have a 14x, 14x.
I got 6 on that.
What'd you get?
1x.
Yeah, it's 1x.
Just minus 3y.
Mm-hmm.
And for the other side, I didn't find anything else, so I just wrote it as is.
Yeah, okay, so that's what they're trying to get at here, right? What is a like term? Can we identify like terms and things? This is an a squared b to the first, and this is an a first b squared. So I think if anything, they're maybe trying to trip you up with that thing, but that is not the same thing. So we cannot add things that are not alike. Okay. Different front back. Okay, I did. I'm trying to debate if I'm going to do groups or not for these. I think these are pretty straightforward, though. I hope. Let's do these two right quick, I think. So if I'm looking at these, and you kind of said it, I'm looking for like terms. If I need to fill in things, you can fill in coefficients of 1. What's the first term that I should look at here? What's the first thing I'm calculating?
X squared.
Yeah, so x squared here and an x squared here. So if I do 1x squared and a minus 4x squared, what is that giving me?
Negative 3x.
Minus 3x squared.
Right.
Yeah. And then the next thing I'm looking at is what my x is.
Mm-hmm.
And so I'm looking there at plus 6x plus 11x. That's going to give me what? Plus
17x.
17x.
Minus 1.
And then that one, I went to a different color for no reason. But there we go. I do 8 minus 9 gives me minus 1. Okay. And the next one looks like 5a squared plus 8 plus a squared minus 4a minus 9. And then you have to, you can put a 1 in front of things.
6a squared.
You can put a 1 for the exponent.
This is 6 square. 6a square.
6a squared.
Mm.
Minus 4a.
Yeah, and that's the way I'd write it. You could probably write it in another way and reshift things. I would do the minus 4a next. And
Yeah,
the
so
last-
the order we write these in, isn't that important then? It's not like it has to be in a certain order.
it, like in general, like it's usually good to put things in descending order. And like it's one of those things, like it's not wrong if it's not in descending order, but in general, the instructions will probably tell you to put things in descending order. It makes life a lot easier in the long run. I'm missing one thing here. I have a plus 8 and a minus 9. I should have a
Minus 1.
yeah, minus 1. And so when we're adding and subtracting polynomials, we add and subtract like terms. And so with that said, I think we got what, 3 more. that are in the same line, I think I'm going to divide y'all up into groups and give y'all like 5 minutes or something on these. Great. This will work. 3 rooms. Let's do 4 rooms.
Two M squared. Minus 5M. Let me see if I can do a whiteboard here. Ah, it's disabled, darn it.
Stable.
It's 5M minus 10, I guess. 10.
Distribute that negative sign is what I would suggest.
Yeah, we want to have a -1 to make it positive.
Oh.
To make it like a adding
Positive
situation.
4. That's right, so I got -7, I guess.
Oh, that's annoying. Yes.
So what do you got for 41?
I got 2M squared minus 7M plus 4.
Okay. Yeah, I got that too.
Let's see here.
See. See. Yeah, those two are fine.
11.
Okay, make sure I got this. Y'all sound like y'all know what you're doing. Sounds like you're on the right track. I want to jump to room 2, make sure they're together. I'm not giving y'all too long on this one. Hunter's. Oh, there you are. I didn't see you. I thought you ran away.
Nope, just leaning off screen.
All right. Are y'all getting this?
Yeah, I'm getting it.
All right. So usually, like, my approach is to distribute things, right? First. Where y'all at? Do y'all have the 3 together?
I'm on 45.
Okay. So you're on the last one. That's probably about. I'll give y'all like another minute, right? Unless you need more than a minute. I think it's probably it, huh? 2, 3. Oh man. Oh no, she's in a room with 2 other people. That's cool. What about y'all? Y'all getting this together?
Absolutely. We just finished the first
Yeah.
2 pages, and now we're double checking number 59.
Oh, y'all are way ahead then. What are y'all doing? I was just doing those 3. I think I'm gonna hit back together.
Okay.
All right.
We're gonna.
You want us to continue or just hold up for now?
All right, head back and we'll go through these 3 right quick, and we'll go to that other one.
All right. Awesome.
Y'all are doing good. Good job.
Okay. Thank you very much, Mr. Stewart. Okay.
Did I end everything? I must really like the groups. They're like staying till the end. I got this done. I gave you 3 problems. 5 minutes. Okay. I think we're back. Almost there. 2 more people. Or did 2 people leave in the meantime? Oh man. Okay, so I got these 3 problems. There are a few ways to do it, but the way like I kind of suggested in the notes, and the way that I would really suggest y'all do it is probably to do some distribution with that negative sign. So if you have to write in -1, you can distribute it to everything there, and so you should get essentially like this thing. And now we're looking at this thing, and we're looking for like terms. And so we look at 4m squared minus 2m squared. That should give me 2m squared. Minus 6 minus 1 is going to give me -7. So if you have to write your 1 in there, that's fine. -3 plus 7 is going to give me +4. Questions about this? I think most people were getting this one, at least.
Mhm.
The next one, if you do some distribution, should look like that. And maybe this one's a little weird because we have 1a squared minus 1a squared. What's going to happen to that? It's going to simplify out. Someone was about to answer that, and I just grabbed it right out from your tongue, probably.
Yeah.
So that's going to simplify out to 0a squareds. I'm going to have 8 and 3 is going to give me 11. 5 minus 2 is going to give me 3. Third one we had, if we distribute the negative sign, should look something like that. There is like 1, 2 like terms, and I guess we can combine in there. And that should be what we get. This one says find the difference of that thing and the other thing. So this one's not substantially different from the other ones that I can tell, where they're just giving us a few words. And so I said, every time you do this, you should probably do that distribution. And with that said, I'm not going to do it in this one. So if I don't want to do this without distribution, I can do w squared minus w squared. How many w squareds am I going to have?
0.
0 w squared. So I don't worry about them anymore. I look at this. This is 1 minus a negative gives me plus 10. 1 plus 10 is going to give me. Ooh, sorry, didn't mean to go too fast for you. 1 plus 10 is 11w. Sorry. Minus 42. And then I'm going to subtract 24. Overall, that's going to be a really negative number. What was that, 66? So most of the time I would suggest writing out and distributing that negative. Is this another adding one? How many adding ones is that? 53. Where did my paper go? 1, 2, 3. Okay. All right, so someone give me this one.
All right. The answer or
Yeah, just go ahead and start. This one's pretty easy. It's straightforward.
Yeah,
We've
so
done a few of these.
so first you add the x squared, so let's get 10x squared.
Uh-huh.
And then negative 2xy plus negative 5xy, and you come out to 7xy, negative 7xy,
Yep, should be -7. And then the last thing,
6y squared.
we just got that guy tagging along. He doesn't have any like terms on the other guy. Questions about this? Am I going too quick? Hopefully not.
No.
We've got a few more
Good.
problems to get through. 53 was an x59.
Mhm.
All right, so how does this one differ?
Now you got 3 equations.
Now we got 3 equations. Okay.
You're adding 1 on one side and subtracting on the other side.
Okay. So how would you do this?
Well, when you combine like terms, I usually treat the negative side as distribute. So I'd try to make it like I would distribute the -1 on the last one. That way it comes just add like terms. At least that's how I did it.
For q, using that negative -3p squared q and a -pq squared. So they're really trying to confuse you probably with all those 2's and 1's and 1's and 2's.
Right.
Um,
Would you just focus on the exponents first, or just
so I would focus on going in descending sort of order, right? So p to the
Right.
third would come first is what I would do. And so we taking care of p to the third, just so I can kind of see what I'm doing here. The next is what, p squared terms. So I think we got a p squared q, and I think we got a p squared q there. Wait. Woo! Y'all didn't call me out on this. I have a p cube here. Oh no, that's a cube. Never mind. So I have a p squared terms next, which looks like this one, and which one? This one?
Yes.
Yeah, so that is -3, and -3 is going to give me a minus
4. Oh no.
3 and
Oh,
3.
6.
Yeah, it should be 6. And I have a p squared q attached to this guy. That looks like my p squared terms. The next thing I'm going to look for is things with 1p in them. This has a 1p. This has a 1p. The rest of it also matches up, I believe. Q squared. And this is like +2 and a -1.
Just PQ squared.
So plus PQ squared. And there's like one last thing I hadn't even underlined yet. And maybe this might be the time to talk about it. This is a descending order with respect to like P, right? If we talk about Q, it's not going to be in descending order. So sometimes you have to select which variable you want to be in descending order, right? If it has multiple variables. Okay. we have a function. We want to find f of 5, f of minus 2, and f of 0. So this goes back to evaluating a function. So if I'm doing f of 5, what is f of 5 going to look like?
8 parentheses 5 squared minus 3 parentheses 5 plus 2.
Yep.
And we'll get 200 minus 15 plus 2.
Yep, and so these, I hope, are sort of kind of like a review. We've done evaluating functions. We've done evaluating functions at a value. And if we do this, this is what, 187, I believe? Is that what I'm getting? Yeah. So f of 5 should look like that. F of what, minus 2 should
Same
look
thing,
very
just-
similar.
Yeah.
Except for 5, now we're putting in minus 2. So maybe this one might be a little trickier because they're doing what? So minus signs, or we're plugging in a negative number. But you should still be able to do this, right? This is a minus 2. When we square it, what happens?
Becomes a positive 4.
Yeah, it becomes positive 4. We do 4 times 8. That's going to give me what? 32.
Mm-hmm.
Here, this is going to be what? Plus 6. And what? Plus 2. I think if we add those 3 things, we're going to get 40. And then the last thing, they gave me f of 0. Is that what the last thing was? I believe it was. Yeah. Okay. The last thing we want to do is f of 0. If you want to, I guess you could go plug everything in. This is one way to do f of 0.
It has to be 2, right? Like it can't
It's
be
got to
anything
be
else.
2. Those other things are nothing but zeros, right? And so if I'm being honest, if I was doing f of 0, I would do none of this work myself. I would look at this thing and I would look, that has an x in it, that has an x in it. The only thing that doesn't have an x in it that's not going to go to 0 is 2. So sometimes it's really easy. 0 is an easy number to plug in, right? Okay. And so now they give us a word problem. A manufacturer of stereo sound speakers has found that the revenue received from selling the speakers at a cost of $P is given by this polynomial function. Find the revenue when P equals $60. So this is a groundbreaking compared to the previous. They're giving us the value of P equals $60. There is an R of P and there is a P. I can plug it into one or the other. They're telling me right there it is a P variable that I want to plug in. So I don't want to spend a lot of time getting into this. We've done similar things before. But we're plugging in P equals 60 into this equation. 3600 times 4. So this is 60 times 60. So like, do yourself a favor and do these things correctly. Don't multiply them. Exponentiate them. I don't know what to tell you. But like, make sure you're exponentiating things correctly, I guess is one of the things, right? I think sometimes people mess up with that. They do like 60 times 2 instead of doing 60 squared is like one of the really common things. So this is a minus what, 1400, and then we have what, 60 times what, 420 gives me. So this is something you're probably definitely going to want to use a calculator on. It's not pretty numbers. I mean, they're kind of pretty, but they're kind of large, right? So this, And this is something this is something that I think we need to work on probably as a class for the most part. This is the thing I got. I want to go back and interpret this. What does that mean? What have I found? So what does this mean? How would you interpret this? So when P is what, 60, my R is going to be 10,800. What do those two numbers represent? So what is the 60 representing?
Dollars.
Yeah, but dollars, but like
The
relative
price-
to what?
The price they're selling the speakers.
The
for.
price that they're selling their speakers.
$60 if you sell 420, the revenue is $10,800.
And so the revenue from selling stereos, I guess I should say stereo speakers, right? Or something. I don't know. What the heck they're doing in the problem. The revenue from selling stereo speakers at $60 is the price that we're pricing these things. And the revenue we're going to make is $10,800. Is that, hopefully, I hope you can like deduce this from the problem, right? This is like what's kind of expected. To be able to pick out the X, know what its units are and what it's representing, right? To be able to pick out your Y, know what its units are, and know that it's representing revenue. And there's multiple ways you can sort of word these things, right? But it has to convey that information somehow. You can make $10,800 from selling speakers at $60. This is also another way to word it, right? Okay. 73. We want to find f plus g of x. We want to find f plus g2. And we want to find f minus g of x and f minus g of minus 3. So I think I'm going to give you all a few minutes to do this. I feel like groups take. It's a reminder. I hope this is what we are doing. Like that was our sort of definition of like f plus g of x is our f of x plus our g of x, right? It is. We're just getting more into like that function notation is all we're doing. With that said, does anybody have the first one?
Yeah, I got for A, I got 7x squared plus 4x plus 4.
Plus 4x plus 4. That's it. Okay, so for part B, let's talk about this. F plus g of 2. We could do f2 plus g of 2. You could absolutely do that if you wanted to do that. Has anybody made an attempt, or am I going too quick?
You're good.
Okay, so as soon as I made an attempt, did y'all do it like this, or did y'all do it some other way?
I did it like that.
You did it like that. You plug 2 into F and you plug 2 into G. Here's the thing: you can do it that way, and it should work. And hopefully, you're getting the same number, and you can check my solution, and we can be happy that we got the same thing. But you have this function right here. You can look at your F plus G as being its own sort of guy. And so I would just take this thing that you just previously found. F plus G of 2 is this thing, 7. And we take 2 squared and we add 4 times 2 and we add 4. So you
That
can
does look a
plug
lot
it.
easier.
Yeah, you can plug it into the previous thing you did. That's something you can do as well.
We can do
There's
that for
also-
every problem. Well, for at least.
Yeah,
every
this is like a new function. We could actually call it its own thing. They're trying to get at like it's its own thing, right? We could actually call it H.
Right.
It's its own guy, like kind of separate from these two. It is made from combining these two, but it's its own new thing. So use it, plug it in, plus G of 2. We can plug that guy in. This is what, 7 times 4, this is 28. Did I miss a minus sign somewhere in there? No. Okay, never mind. Plus 8, plus 4, that's it. Sorry. And what you should have got is this gives me 36 plus 4. I think it should be something to 40.
Yep. So I got.
Okay. And then next thing is what, F minus G of X? F minus G of X. That's like F of X minus G of X. Okay. So the first thing I wrote out is that F of X minus G of X. So I distributed that negative to my G of X. So after you do some distribution, make sure your positive and negatives are going the right way. I think it should combine to minus 3x squared minus 12x minus 2.
I got.
And now we're back at that dilemma. Do we want to use f minus g of x, or do we want to like separate it and do them each separate? Either way should work. But sometimes you can save you a little bit of time just using what you previously solved.
Oh wait, real quick, Mr. Sievers.
Uh-huh.
For C, wouldn't it be 4 instead of -2? 1 minus -3.
Did I miss the negative in there? The original thing. It should be 1. So it should be a positive 1 and it should be a -3.
Right.
So I distributed the negative here already.
We're subtracting the 2, right? So it'd be like 1 minus -3.
So it would be like 1 minus 3.
Oh, okay. All right, yeah.
I already distributed the negative, so there shouldn't be any more subtractions. It's just like the
Okay.
+1 and a -3.
All right, my bad. Thank you.
Yeah, that's fine. That's it. And so the last one was what? F minus g of -3.
Mhm.
And so this is going back, like I said, you can do it separately. We can do f of -3 minus a g of a -3. That's going to be a lot of work. What I want to actually probably do is just throw my -3 right into this thing. If I throw my -3 right into that thing, it should look something like that. There we go. Let's put them out. -3 minus 3 squared, minus 12, minus 3, and a -2. I do my PIMDAS. -3 squared is 9, times another -3 gives me -27. I got what? Plus 36. I got -2. Doing PIMDAS order of operations should give me 7. Okay. Questions about that? It's plugging things into functions. I guess the new thing that we're doing is combining functions to create a new function. Okay. So where are we at now? 5. 69, 73. Up. 5. 6. Got too many pages. Oh, this should be pretty easy, hopefully. What is the strategy for multiplying these things?
Multiply the coefficients and then add the exponents.
Yeah, exactly. So we're multiplying coefficients. -10 and -3 is going to give me +30, right? And I go x, that is x5 and x3. So this should be x to the 8th power. So this we're multiplying monomials by monomials. This next one we're multiplying monomials by a polynomial. So these, I think, I'm hoping they should be kind of straightforward. It's just some distribution. So we got to distribute this guy to everything. Just start calling on people. Is Elliot here?
Yeah, I'm here.
What are you getting for this one?
Okay, for that one you do -5m3,
Oh, that's it. -5 and 3. And then we got what?
and then for the other one it is -15m, and then the last one will just be -18.
Okay, so this one, we have an m here. And we have an m here.
With the 2.
Yeah, this should
my
be m
bad.
squared. And this is -15 and -18. Yeah, I don't know. That's when you're probably grabbing your calculator and going 5 times 18 is 90. And if it's negative and negative, this overall should be what? Positive. There's a 90, and there should also be what here?
Yeah, I'm not too sure about that.
There's still that m coming from that minus 5m.
Oh, okay.
All right, you see it?
Yes, I.
All right. I'm just making sure y'all are still awake. I gotta call on some people. Some of y'all are quiet. I don't know if you're sticking around. Okay, so this one, if we have minus 3x squared y squared, we're distributing this thing.
Minus 21?
Yeah, the first thing is minus 3, and 7 gives you minus 21. X to
And
the
then I got to the
4th power, and then anything else here should be a
the y squared. So if we have something left over like that, we just keep it like that.
Yep, it's still there.
Okay.
You're just like multiplying it by 1. Ooh, someone's vicious. So the next thing, minus 3 and 10 is going to give me what? Minus 30. And I have an x squared, and I don't see it here, but there's a single power of x. So 2 and 1 is going to give me x to the
third,
third,
and y to the third.
and y to the
Sorry, y to the third.
Yep. And then the last thing, if we don't see a coefficient, we can always put a coefficient of 1 if that messes you up. But we have a minus 3 and we have a minus 1. Overall, this is going to be positive. Yeah, it should be 3. We have an x squared here. We don't have any x's here. So this is going to stay x squared. But we have y squared and y squared. This is going to be y to the, oh man, I'm running out of room here. 4th power right there. Okay, so this is one way you can do it. I didn't do it. I don't think I did this in the notes. But if we're going to do distribution, if we're doing monomials or binomials, there's this thing we can do called the box method. So if you want to do the box method, this is completely a valid thing to do. If we do the box method, and it's probably easier just to do these without the box method, to be honest. But we're going to look here. If we do this one, this is y times y is going to give me
Y squared.
Yeah, y squared. Y times 9 is going to give me positive 9y. 3 times y is going to give me positive 3y. And 3 times 9 is going to give me 27. So if you wanted to do this one, 187 with like foiling or something, you could completely do it that way. You could do it the way I showed in the notes. Any way you want to do it, that's a valid way is good. But if we're looking here, we have y squared. We have 9y and 3y is going to give me a total of 12y. So I have some like terms I can combine either before I put it, either in the box or after the box, wherever you want to do it. You could write out every single term you have in there. I get minus 3y. Let's go back. It's going to give me this thing. And I don't think distribution is probably the hard way to do this. But like with the box method, I'm trying to set you up for when we do like factoring. So a lot of you might go to the box method to do factoring. Okay. Do we have a few more? Multiplying binomials by binomials. And then we have a few multiplying polynomials by polynomials. So 193, 201, 203. I'll give y'all just a few minutes to get those things down. I didn't remember this section being this long when I looked at it earlier. It's long. It's got quite a few problems.
Yeah, and the last part is just a review of, it's really weird because there's tons of problems on this one and then there's like 6 tomorrow. Oh, no. Okay.
Yeah, I think these 4, and then 209 is like as hard as it gets. That's what it looks like, and then the rest are kind of special cases or mixed practice. Okay. All right, so I think I need to get with it a little bit. But this one, we're doing some distribution. So 6p times p should give me what? 6p squared, and I have plus 6p times 1 should give me plus 6p. The next thing should be plus 5p plus 5. So that is the distribution step. So if you get that much, you know how to do the distribution part. After you do the distribution, there's usually a little bit of cleaning up to do. So this is what, 6p squared plus, usually, won't be always, but a lot of times it'll be in that middle. 6 plus 5 gives me 11p, and I'm doing plus 5. All right. The next thing looks like what? 2xy plus 3 and 3xy plus 2. If the first thing I'm doing here is 2 times 3 is going to give me 6. I have an xy times an xy. That
X
means
squared and Y squared.
Yep, I got 2 x's. I got an x times an x, and I got a y times a y there. So it looks like 6x squared y squared. Remember, you're adding your exponents, you're multiplying your constants. So that's just those first 2 things being multiplied. The next thing, 2xy and a 2, is going to give me plus 4xy's. The next thing is plus 3 and 3xy is going to give me what? Plus 9, and it has an xy attached. The last thing is 3 and 2 is going to give me plus 6. And if you get this, you did the hard distribution step. There's one little thing you should do. And it's that thing in the middle. They look alike the same thing. That's an xy and that's an xy. I can do a 9 and a 4 gives me 13 of them xy's. Last guy. Y squared minus 7, y squared minus 4. If we do y squared times y squared, that's going to give me y to the fourth. Okay. If I look here, I got y squared and a minus 4 is going to give me minus 4. And there is a y squared attached to this. The next thing, I got a minus 7 and a y squared. It's going to give me minus 7 y squared. And the last thing, minus 7 and minus 4 gives me positive 28. Ooh. Let me move that so it's visible. Okay, so this, if you got this far, you did the distributive part step right? I can't even speak anymore. You did the distributive step correctly. So this is y to the 4th minus 4 minus 7. I believe that gives me minus 11. There's still a y squared attached to this thing. and I'm doing plus 28. Okay. Are there any questions about this? So I know we said like those exponent properties and things kind of build on themselves, but those exponent properties, you really have to get them down before you like start doing this sort of stuff, right? And the better you have this sort of stuff down, the better you're going to have factoring down. A lot of the factoring's just going the other way. And so if you got this sort of thing down, you can check your factoring a lot better. So now we got a binomial by a trinomial. So what is the process to this? And you can do the box method on this. It's going to be a 2 by 3 box. If you want to do box method, that's a thing you can do. But I like to go through and just go with the first thing. So if I do a times 3a squared, what is that going to give me?
3a cubed.
3a cubed. So I want to give you just like 1 minute on this. I want y'all to try this distributive step. Probably all I have is 1 minute. Okay. Okay, so I gave you 1 minute. I'm multiplying everything by a. I don't know how to say this, but if it has an a, it's going to go up by a power of 1, right? If it doesn't have an a, we're going to tack an extra a on there. So 3a squared is going to become 3a cubed. And a to the first power is going to become an a to the second power. And then the next thing, I have a minus 5. It didn't have an a. Now, congratulations, you have an a. Isn't that what you like to hear? But anyway, the next thing I'm going to do, so where's my other color go? And it's like about time, so if you got to buzz out of here, I guess I can understand. But this is my 10. And now I'm doing that 10 by those other 3 things. So everything gets multiplied by 10. There's no variable. We're just going to move everything over like a decimal place. We're going to add a 0 to everything. We're going to go to plus 10, and 3 is going to give me plus 30a squareds. I'm going to have what, plus 10a. And I'm going to have a minus 50. Do I have everything on here? Yeah, we go. So this is going to take up probably a whole line of your paper. It's a long sort of equation. But it shrinks down a little bit, right? So we need to shrink this thing down a little bit. We can combine some like terms. We have a 3a cube. I think that's the only a cube we have there. So this guy we already took account. What do we need to look at next? Them two, hopefully. My a squareds. If I don't see it, I can write it there. It's a 1. This one should be what? 31 a squareds. The next thing, I got these guys out of the way. I got a minus 5a plus 10a.
5a.
Plus 5a. 10a. Okay, so minus 50. Only thing I have left I haven't accounted for. And we look here, we have a cube, we have a square, we have a single, we have a constant. That's probably as much as we're going to be able to combine there. Okay. And so now I feel like we've done, like for the most part, we've done the hard stuff. This is a sort of review. And in the notes, I mentioned this. If you see something like this, I swear if you tell me something like 4y squared minus 6z squared, I'm going to get so angry. Don't do this. Like, don't. That is not what this is. You cannot do that. Even if I said 9 or something, I don't know. I probably did this wrong, right? Don't do that. What should you do if you see a polynomial, anything that's more than one term and it has a square?
Write it out twice.
Write it out, write it out, write it out, write it out. So 2y minus 3z and 2y minus 3z. And now since we have this thing written out, 2y times 2y gives me 4y squared. Now I'm looking 2y minus 3z is going to give me what? Minus 6z's. 3z, now I'm doing this 3z and this 2y. That's another minus 6z. And the last thing is 3 and 3 gives me positive 9 and I have a z squared. So if you don't write these things out, there's a good chance you'll miss your middle term in there. With that said, like I'm hoping you're making an honest attempt at that next thing that's there before I start doing it. Try to beat me to it.
Would the negative 6z, two negative 6z's have a y in it also?
Did I do that wrong? I did do that wrong. YZ. Good call. You are paying attention. That was just a check. No, I completely got that. Missed it. 253. And I said it, and if you didn't do this, I'm already angry. So write this thing out. So what's the first thing I should have here?
So m to the 6th.
Yeah, m to the 6. And the next thing looks like what? Minus. Ooh, there's an 8 there.
Minus 8 n m cubed, right? Cubed n.
What, camera froze? Where you at? Well.
Yeah, I did.
Okay. Well. I gotta plug it in, I guess. Well, scratch that.
Maybe try leaving the meeting and coming back.
Yeah, my phone's dead, so it's not gonna work. So I'll have to figure out something else right quick. So what I want to do. I'm gonna let charge just for a second.
Can't you use like the whiteboard?
Yeah, you use the whiteboard. Share the screen. Okay, so where was that? M to the 6.
I think there's a text function also.
Yeah, but then exponents are going to be a pain in the butt to do. I would be willing to bet. Minus M to the 3rd N.
I need to learn how to do that. Is that part of Zoom?
Yep, it's on Zoom.
Okay.
And then the next thing we have is minus N and M to the 3rd. It's going to look very similar if you said like minus 8N M to the 3rd, right? It's going to be the same thing. So it doesn't, I don't know how to tell you, but it doesn't matter so much like what order you write these things in, right? Whether I write M to the 3rd N or N M to the 3rd, they're going to be the same sort of thing. And then the last thing I have is a minus 8, and a minus 8 is going to give me overall what, plus 64. And have an N times an N should be 64 N squared. That's a square with a 2. Is this any quicker? Let's see. Are you gonna come back on, phone? And so what can we do here?
Combine those middle terms.
Yeah, and so we're going to combine these middle terms, and I'm not going to write this all over again because it's going to take forever. But if I combine these middle terms, what are they going to end up being?
Minus 16N to the 3rd N.
Yeah, so the minus 8 and the minus 8 should combine to a minus 16. Nope, it's dead. Okay, so the next thing, if I bring this up on Blackboard, that'd be the smartest thing, huh? Then I can annotate it. I'll get it to you just a second. Homework worksheets. And it's on. Here we go. Now I can probably annotate on this thing, and it will be a lot easier. Let's do the mouse. Let's go down. Where are we at? These guys. Okay. So if I multiply these things together, I do 9 times 9 is going to give me 81. I have a c squared.
I think you can make a smaller text box with smaller text and then use that as your,
Yeah, it's
as
just like,
your things. What do you call it? Yeah, so,
As
so
the
write the
exponent.
2, write the 2 and then shrink it.
it's there, 81 c squared. And the next thing we have there is going to look like what? 9c times minus 5 is going to give us,
Negative 45.
and it's got a c attached to it. The next thing is a 5 and a 9c is going to give us
Positive 45.
positive 45c. And the last thing we see there is plus 5 and minus 5.
Negative 25.
Should be minus 25. Okay. And if we notice something like this, they're trying to get at this thing called product of conjugates. Okay. What is this going to end up equaling?
81c squared minus 25.
Yep. Yeah, there should be a little deuce up here. Ooh. Oh, Jesus. And then they may make us do it for this one. 15 and 15. They're going to make us do some real math. Okay. 15 and 15, 8. What is that? 225? My phone's back up in service. Come on.
Yes.
So this is 225. This is m to the 4th. And then we have 15 and 8. So 15 and 8 are going to give me what? 120. So there's a few ways to write this. Minus 120. And I have m squared n 4th, m squared n 4th. And then I'm going to have a plus 120, and it's going to be the same thing, m squared n 4th. And then the last thing is going to be minus 64. And this is going to be n to the 8th, I believe. So I got to fill in some exponents here. This is going to be m to the 4th. 120 was m squared into the 4th. So this one is squared. This one is 4th squared into the 4th. They are the same powers is hopefully what you're recognizing. Those are the same like sort of terms that are going to end up in the middle. So if we multiply conjugates, what they're trying to get at is like this sort of thing right here. We have the same thing that's plus, we have the same thing that's minus. So if you really want to look at this thing, I don't want to rewrite this and rewrite it with this annoying font. Oh no, let's not do that. I was hoping I'd delete part of this, but if I just draw a fat line through it. This is plus, this is minus. I just want to scratch through this thing. So now this is no more. That's like a plus 0 there, right? Stay there. And so overall, if I'm looking at this thing, what is going to be left over? I believe it's going to be that 225 m to the 4th minus 64 into the 8th. And if you want to come up with like a sort of like short way to do these, if you can understand that, go for it. If you want to write out that middle term, go for that. But what we're doing is we're looking at what? 15 m squared and 15 m squared is what's giving me this 225 m to the 4th. And what's giving me the minus 64 is the second term. So if we have conjugates, one way you can do it is just multiplying the first terms and multiplying the second terms. Those middle terms should simplify out if we're doing conjugates correctly. Okay, mixed practice. What are you getting from this guy? J squared minus j squared, no more j squareds. Minus 8 minus 2 is a minus 10j. We've done enough of these. So minus 10j, and this is minus 27, but then we were going to add 12. So overall, that should be negative 27 minus 12 gives me 15. What are we doing over here? looks like we have 2x squared times 2x squared. That should be 4x to the fourth. Oh, this is conjugates again, huh? So the first thing is 4x to the fourth. I don't want to write all that middle stuff out. I want to see if we can do it maybe the quicker way.
Minus 3y to the 8th.
What's the 3 times 3?
9y to the
Yeah,
8th.
it should be 9y to the 8th. That's it. So if we multiply first term by first term and last term by last term, this is 4x to the fourth. And this is a y to the fourth. Y to the fourth gives me y to the 8th. So if you want to do the shortcut, do the shortcut. If you have to write that thing out and do that middle term and subtract that middle term, you go for it. I don't know what to tell you. Like, both are valid ways to do them. And I think we're at the last problem now. I'm sorry I held y'all a bit over, but we're there. Let's clear everything. They're clear. Everything. F of x is a x minus 1. G of x is that thing. And so now we're doing f times g of x. Okay. So does everyone understand what this first, I hope you understand what this first sort of notation means, right? So f of x times g of x is going to be what? My f of x, and then I'm going to multiply that by my g of x. Why is it? Okay. Okay, I think I can do this now. Let me try to get. I can start up. Please start up. Okay, so now I can do some paper. It's a lot easier just to do it on paper. I don't know, I've been trying to annotate thing on a mouse. It's just so hard. If I had a tablet, it might be a little bit better, but it is not fun. So let's do this: x minus 1 and 4x squared plus x minus 5. So I'm hoping you do this all on your own. We're going to increase everything by a power of x. So 4x to the third plus 3x squared minus 5x. And then everything next is we're going to multiply everything by a minus 1. This looks like minus 4x squared. A minus 2x and a plus 5. So we're looking at this for like terms to combine. This is 4x to the third. Plus 3x squared minus 4x squared should be a minus, almost did the wrong thing, minus x squared. Minus 5 and minus 3 gives me a minus 8x, and I have a plus 5. So this is my function. This is part A, says f plus g of x is this thing. And so we have gone over this already, but if I want to do f plus g of a minus 2, there are a few ways to do it. You can go plug that minus 2 into each one of those functions separately. But if you did the work, save a little bit of time, we should be able to plug this into our function, minus 2 of a minus 2 squared, minus 8 of a minus 2, and then the last thing I have is a plus 5. So I'm running out of room there, but This is 4. This is a -8. When I calculate that, this is the minus, and then I have a minus squared. So overall, this is -4. This is a minus and a minus. So overall, this is +16 and +5. So this is -32, -4. So right now, we're just doing order of operations. I'm not trying to spend too much time on something that's order of operations, but this is -36 + 16 is a -20 + 5. I believe that's giving me -15. Is that right? I did that in my head, so hopefully. -13. That's it. And that is the last problem for today.